Hello, everyone, and welcome to today's session, your firm's Untapped Diamond Mine. Today's session is all about how 3E performance testing can yield a great return on investment on the product that you've already invested in, Elite 3E. My name's Bim. I am Executive Vice President at Helm 360, and today I'm joined with Sue Mickelsons, our Director of Sales, who will be here throughout the session today to answer any questions that you have. So please feel free to throw your questions into the chat and we'll be happy to help and answer questions along the way. So before we get started, just a little bit about us and Helm 360. So we've been helping law firms for a number of years now, over 140 3E firms with their migrations to the 3E platform. And that's everything from consulting services on how to use the application to development services in the IDE, as well as template development, integration development. And one of the big areas that we've been very successful in is QA testing, of which performance testing forms part of the package. And that's something that we're going to be digging in today in a little bit more detail in terms of how performance testing can kind of help de-risk some of the project go live challenges that we've seen time and time again. We are a product and services company, so we also have a product called Termi, which is an AI-powered BI chatbot, which integrates with 3E as well as other best-of-breed solutions in the market and really allows you to easily interface with data that could be in a multitude of systems as well as action data through simple natural language. So when we're considering talking about performance and performance management and performance testing, really, the first thing that comes to mind is the approach that you take and the kind of mindset that you have when it comes to seeing the success factor that is performance of the system that you've bought, right? So when you're considering a rollout of a solution like 3E, the first thing that I always tell customers is that as well as the functionality and what it's going to deliver to the business in terms of that core business function, all of that kind of goes to pot if the performance of the system doesn't stand up or the system falls over, right? So it's really important from the outset of your project to realize that performance, the responsiveness of the system should be one of your major success criteria to determine the success of the project. And in my experience, there are really two approaches to this. One is reactive, and the other is proactive when it comes to understanding how 3E will actually perform under peak usage. Now, it may not surprise you to hear me say that really my recommendation is the proactive approach. Simply because it mitigates a lot of the risk that you have if you don't go down that route and you kind of go down a more reactive mindset. When we kind of put this into context, when we talk about reactive, what we're really talking about is customers who take a decision to wait until they get to the UAT phase of a project, start to do some anecdotal testing and realize that certain functions are running a little bit slow and really put some doubt in their mind in terms of whether the system can actually scale up. We've only got a limited number of users on there and already experiencing performance issues. So in those kind of scenarios, what you have to understand is that there's impact on the user's perception because you've got your core testers that are really taking valuable time away from their day jobs to help get this project live. And at the end of the day, if the performance is bad at that point, then that can erode their confidence in the product. It can also be quite frustrating when you have to start a test and then repeat a test multiple times simply because the system is not performing well. So these kind of things can be really frustrating and can ultimately lead to extensions in timelines, repeating a UAT cycle, which ultimately means, resourcing those UAT cycles with both internal resources and external vendor resources, which ultimately adds cost to the project, which could have been avoided with some foresight and planning around performance testing. The other option is, if you don't experience major issues during your UAT, waiting until you go live and then monitoring and dealing with it at that point. And that again is like a very risky approach because ultimately once you go live, there's a few key issues. One is that your impact is much, much higher because at the end of the day, if the system is not performing and you are struggling to get bills out of the door, fundamentally that's affecting your bottom line. It's affecting your financials and your ability to collect money. Secondly is change management becomes a hell of a lot more difficult, right? Because at the end of the day, once you're live, making changes is in your infrastructure, your database level, your application level, all becomes a lot more difficult. and a little bit more risky because you have a limited window of opportunity to kind of test and deploy those, and really make sure that they are good sound changes and not impacting other things around the functional product itself. So really the proactive approach is really designed to give you peace of mind, really make sure that the system can scale up for the number of concurrent users that are going to be using your system, and ultimately, meet the demands of your business in a nice and smooth manner. So I often get asked the question, I'm buying a product that's been tried and tested at 200 plus customers across the globe. Surely I don't need to worry about performance testing. All I need to do is get it in, configured, convert my data into it, and ultimately I'm good to go, right? The type of mindset is that, Thomson Reuters will have done some level of performance testing. They obviously have done a good job of making sure that it functions for the use cases that they would be testing. And then from a vendor perspective, some customers come to us saying that actually performance is not my problem, right? It's a vendor issue. If the product doesn't work in my environment, then it's their problem to deal with. So I'm just going to let them deal with it. But in both cases, my answer is very simple, and that is that ultimately no 3E system is the same, right? And there is a responsibility on you as a customer to make sure that you are responsible for really the underlying infrastructure that is there to support the product that's sitting on top of it. So there is a kind of a shared responsibility and ownership in terms of performance. So when you think about 3E as a product and you kind of dissect the elements of it, your core infrastructure is really your responsibility unless you are hosting with Thomson Reuters from a cloud perspective. Secondly, like the core product in terms of the performance there is a vendor responsibility and really something that they are responsible for. But then you have to remember that you've got your customization layer, your configuration layer, that again is your responsibility in terms of some of the decisions that you make throughout your project to, add specific logic to do a certain thing. All of those kind of add some level of complexity to the system that is not necessarily a product issue, but really a logic issue that could contribute to a performance issue. So the bottom line is no 3E system is the same, and it's important for us to recognize that when we're thinking about performance of the system and performance testing in general. And here's why. First is infrastructure, right? So every customer that I've been to over the last 20 years has had some variation in terms of how they've deployed 3E. First point of call is whether they choose to go physical route, physical server route, or virtual route. And then when you think about virtualization layer, whether they're going with Microsoft technology, whether they're going with VMware, all of these things can have an impact on performance and need to be tuned differently in order to get the best performance out of the system. Again, from a load balancer perspective, which is obviously used to distribute load, that can vary in terms of makes and models, how you configure that load balancer. Every load balancer comes with its own bells and whistles to kind of help you fine tune how it handles load distribution, as well as bringing data back from those servers from a caching perspective. So decisions will be made throughout the project to fine tune those. And a lot of the time, the load balancer that's in place is not necessarily just used for 3E, it's used for other product areas as well. So may have certain configurations that apply to certain products and not to others. So there is, at the end of the day, some variation there. And then when you think about, especially now more than ever, we have many customers now making a decision to actually host 3E in their own Azure cloud. So that comes with its own challenges and decisions that need to be made around that. And obviously those can vary from customer to customer. Secondly is on the configuration side. So again, every 3E system that we will go to will likely have a different version of 3E. So you're using a different product version depending on when you go live or when you've upgraded. So your product release is different, which means the core code base that's being run is slightly different. And obviously the configurations that you make and the configuration decisions that you make throughout the project are specific to you, right? So how you choose to configure 3E will and can have impacts on how the system performs. For example, things like your system max row settings in 3E overrides can have a big impact on the workload demands if you set it too high, right? So things like that can influence performance overall. And then the customization layer, as I mentioned before, can have very big performance costs associated with them, depending on how complex you go. And then integrations, right? So again, every customer is different in terms of what downstream and upstream systems they might have in place. So, time entry systems vary, cost entry systems vary. How you integrate may vary in terms of the technology. Some people use BizTalk for some loads, perhaps like the out-of-the-box stuff that comes with 3E. A lot of customers will have additional integration methods using Untapped, for example, or SSIS to kind of load data in and out of the systems as they need to. So the integrations, again, have some impact in terms of how we kind of see performance from a systems perspective. Finally, is around the user experience and perception of users. So obviously, depending on which system you've come from, this can have a big impact in terms of what your expectations are, right? So it's really important to make sure that you're thinking about 3E from a benchmark perspective in terms of defining what is good performance, first of all. So what is the expectation? How long should a build take to get generated, for example? And what is acceptable performance to the firm so that performance is kind of benchmarked. And also comparing that to other sites. Like one of the good things that we've been doing for customers for a while now is as we build our data set in terms of testing and automating tests for various customers, one of the things that we do is we measure the time it takes to execute some of those tasks. And then we keep a running list of those so that we can basically see what average performance across a number of 3 firms should be to generate a performer, to reverse a bill, to make an edit, or whatever it might be. And what that allows us to do is then when we go to a new customer who's doing load testing for the first time, it's very easy for us to identify whether they are in the right range of performance, right? So if you're way off what 10 other sites have experienced in terms of good performance, and those sites may be live, then really we need to hone in on where that issue might lie and why your system is not performing the way that it should. So what are the steps to success? So we have a lot of experience working with 3 customers of varying sizes and configurations to help them benchmark their environments, troubleshoot performance, really hone in on those bottlenecks, and then ultimately solving those problems so that they can move to a smooth and performant go live. And as a result of some of the experience that we've had doing that for many customers, what that's led to is really this 7-step process, which is a tried and tested methodology, which really starts with baselining your system and then kind of moving forward from there. So step 1 is really making sure that you've got a good starting point and leveraging best practice that's out there from both your vendor, Thomson Reuters, but also from other experience that we've had with other customers, right? So what we really do is start with a health check, make sure that your system is configured the way that we would expect it to be configured, and making sure that we've got a good, clean starting point, and ultimately making sure that those best practices are in place. So, we talked a little bit about AV, making sure that your antivirus policy is in line with what we expect to have, a good outcome. We also, with every performance test that we do for a customer, we will always walk away with some recommendations and some findings that have been the cause of poor performance. And that could be anything from, an infrastructure change to a cloud configuration issue to a template logic issue. It can really, really vary. In some cases, a core product issue within 3. But all of those things really translate into lessons learned, which we then apply to the next one that we do, right? So ultimately, you gain some experience with what is working for other firms, and we apply those best practices to every firm that we go to make sure that we've got that good starting point, right? So we're not reinventing the wheel each time. So baselining is really important, making sure you've got a good starting point. Where you're starting. That you've got a system that has all of the code from a customization perspective, the configuration from a configuration perspective, all in place. So you're in a place where you've got the system really where you expect it to be and as close to what you're going to go live with as possible, so that our starting point is clean and relevant, right? Which we'll kind of talk about in a little while. Second step is to really deploy tooling and monitoring, right? So ultimately what we want to be able to do to be successful is firstly automate load so that we're not sitting there and plugging in data manually. So the automation framework is really, really key in putting together a series of tests that are relevant to you. And what we do is we really start with a good starting point, which is, again, a tried and tested set of routines that are based off month-end load or year-end load type scenarios. So making sure that we're considering everything from the initial, master file entry that will be happening all the way through to bills that will be generated, all of those actions that will be happening on, during the performer edit stage, and the processing of the template to make sure that that logic is in place as well. So all of that stuff needs to be automated and it needs to be scaled up, which is really why we want to make it relevant to you and make sure that it does what you expect it to do and is in line with the type of load profile that you're expecting to see once you go live. Monitoring is a key part of it as well, because what we really want to be able to do is assess the impact of when we execute that load for 500 users, for example, that we are monitoring each component of the system, and that's everything from core 3E in terms of what it's doing and how it's performing, really looking at it from every single angle. So looking at it from an infrastructure perspective, core product perspective, database perspective, and really gathering all of those statistics while the load test is happening in a controlled way, so that we can then report off that and give you a really good understanding as to how your system has performed, and give you, the charts and the data that's associated with it to really give you the confidence that your system can sustain that load. Step 3 is really personalizing the framework, right? So really what we want to be able to do is make sure that the test is as relevant to you. The way that I kind of think about this is that there's a balance to be had here, right? At the end of the day, we could be sitting here for a very long time building an exact automation suite that is relevant to you for every single customization that you have. That in reality is not really what I would recommend, because you're not going to get a really good bang for buck by doing that. Our recommendation is to start with what's known as a tried and tested method, which is our standard automation suite, which is basically covering that month end or year end scenario. So covering those core processes, because that's really a really good starting point to be able to give you a litmus test of the system to see that it can perform the way that we expect it to. And what we do as part of the personalization stage is really work with you to understand what has been customized, what integrations are in place, what security is in place from a data level security perspective, so that we can understand the core components that we think would impact performance, right? So we're actually using our 3E expertise to say, if you've made a couple of edits to a form, or you've added a really simple logic to a particular app object, then really that's going to have very minimal impact in terms of overhead, right? So we don't really care about that too much. What we do care about is where you've made decisions that add some level of complexity, add deep level of logic to an existing process, or that you've kind of reworked a 3E process into something that's very different to what it stands as today. So looking for those outliers is really what we do during the personalization stage, and we work with you to understand any of the customization decisions that you've made to make sure that the test suite is really built for you, and that we can really adapt it to make sure that it is relevant and testing the key components that you have. And then obviously from a volume perspective, what we want to be able to do is assess firstly how the system is going to kind of sustain the load for your typical concurrent user count, and then scale that up to see what the next level is, right? So see how far the system can go before it breaks, so that you have a really good idea as to what your growth trajectory looks like, and how that's going to impact you over time. Step 4 is the core execution of the performance tests. At this point, we've baselined, we know we've got a good environment kind of ready to go in terms of the test suite. We know we've got relevant tests, and we've run through them from a functional perspective to make sure that they all execute cleanly. And now what we do is execute the performance test, and that really consists of 3 key stages. So first is to conduct a load test, where we're doing a short ramp up to your active concurrent user count, and that's done in a short window of opportunity, just to kind of do an initial assessment of how the system kind of copes with that load. We then move on to a soak test, which is really a longer test duration, where we're kind of throwing 90% of what your expected load would be, but for a longer duration. The reason why we do this is really to identify any other bottlenecks that might happen over a period of time. So typically this uncovers things like memory leaks, bad code that's causing unnecessary CPU cycles or CPU loops on your WAPI servers, all of those kind of things, so that we can really hone in on those and understand why that's happening, and really hone in on the code that's causing that, so that that can be addressed. And then lastly is the stress test, which is really taking the system to its maximum, so that we can give you confidence that the system can grow with your firm and usage, to make sure that the system can stand up in those kind of scenarios. Once that's done, what we do is we produce a report at the end of the performance test, which really gives you all of the statistics in terms of how did the CPU on the SQL Server perform, how did the memory hold up on the SQL Server, all the way through to did the load balancer distribute load evenly. All of those questions will be answered in the report essentially that gets produced. Most importantly is the actions, right? So with each of these load tests, what will happen is we will uncover varying things, which could consist of infrastructure issues where things need to be solved. Say, for example, we're seeing poor disk performance on the SQL Server. That may come up as a recommendation to go and explore that further. Or look at AV if that's interfering with the disk read writes, those kind of things. Core product issues can come up, so where you're using the product a different way to somebody else and who may not have experienced the performance issue with that 3E version that you're running. We will help to identify what that looks like so that you've got everything that you need to be able to take that to your vendor so that you can then log an issue with them so that they can address that through a hotfix or new release. And then taking it down to the customization level. So anything that we see in terms of workload that's being executed that could be contributing to performance issues from a customization perspective will be identified so that we can then make recommendations on that. So really, it's a 360 view of how those problems can be solved. And it's very important to note that a successful load test and performance test is only possible if you have the experience of all of these angles, right? It's not just about infrastructure. It's not just about knowing 3E. It's understanding the code that can be in place from a customization perspective. It's understanding the configurations, kind of the release components, how IIS is configured for 3E. All of that knowledge and experience is really key to making sure that we can make good recommendations and that they're holistic across the board and covering all aspects of what needs to be covered to be able to get you to a point where you can have a performant 3E system. Step 6 is then once all of those suggested actions are done and in place and tested individually to make sure that they've done what they needed to do, we really need to repeat the test to make sure that we can run another full performance test and compare that back to the original to make sure that we can see some improvement and benchmark that improvement so that you can see what the real world usage is going to look like. And that's a really key step because obviously once we make lots of changes, or whether it's a few changes or lots of changes, once those changes are made, it's really important to make sure that a retest happens so that we can make sure that the impact and measure the impact of that change in a controlled environment so that we're really making sure that the recommendations that have been made turned into something that was beneficial in terms of a performance gain. So that's step 6. And then really it's taking you live, right? So going live with confidence, that you know that the system can sustain the load and really having a happy experience and just allowing you to focus on functionality, right? And enjoying the product that you've actually bought to improve how you do business. So if we break down some of these components a little bit further, when I kind of think about performance testing, I think about infrastructure and functionality really as the two core components. And when we think about infrastructure at a very high level, you can kind of see the different areas that really we focus on and where most issues come from. Let's take a step back and try and visualize what the high level, core components of your 3 infrastructure would look like or could look like. And we really start with the user. We start with the browser that they're running and the workstation that they're running, and what kind of things can kind of come up at this level that impacts performance, right? And this is everything from WAN latency. So if you're accessing, depending on how you're accessing 3E, if you have, for example, remote offices, what impact does that have in comparison to somebody who's sitting in the same office where your 3E servers live, right? So for example, we have a customer whose base is in London, their servers are in London, so their local users will be having a great experience with 3E, but they may have remote offices in Tokyo, for example, and when the Tokyo users are accessing the system, they're coming in over the WAN, so they're opening a browser on their machine and coming over a VPN tunnel to access 3E, and the performance is typically going to be slower from that location. But how much slower is the question, and is it acceptable performance? So what we're able to do in those kind of scenarios is make sure that we've tested for latency, network latency, and how that is going to impact performance by setting up an additional performance testing node from that location, which is just a virtual machine that allows us to kind of replicate load from that environment. So that while the core testing is happening, we have one system running that's replicating load from a London perspective, another system replicating load from Tokyo, so that we can actually measure the response times and compare them back, right? So that it gives us a very clear picture in terms of what the network latency adds to the response times. And then that gives you a very clear picture in terms of what the user experience is going to be looking like, and how that scales up once the system is very busy. Because the other thing to consider is that if you've got nobody on the system and you've got one user in Tokyo hitting the system, maybe they'll have a decent experience. But what happens when 500, 600 people are on the system at the same time? What happens then? Does the system still stand up, and does the performance still fall into the realms of acceptable performance? So those are some of the things to consider from a user level infrastructure piece. And then the other things that come up quite often is browser configuration. So 3E leverages local browser cache, so making sure that those kind of things are considered. And obviously AV on the local workstation can have an overhead depending on how it's configured for on-access scanning in particular. So all of those things are considered from that perspective and need to be tested to see how they kind of stand up to a load test. Then from a load balancer perspective, making sure that the load balancer is distributing correctly, that it's configured correctly for persistence, to make sure that users are not being unnecessarily switched between WAPI servers. So making sure that you've got confidence that as the system scales up, that distribution is actually happening correctly is a very key thing we want to measure, and to make sure that those sticky sessions are happening to make sure that the continuity is there in terms of performance. Also, like making sure that from an application server level that we're testing all of the elements of what's there, and that's really where your core code base is, right? So making sure that from a func perspective that we've considered all of the impacts of the func in terms of, we know, for example, that when the WAPI start up, they're going to be pulling the code from the func so that it's now in memory effectively on the WAPI and executing within the IIS pool. So what impact does that have in terms of startup times of the WAPI? Is the performance of that good? And then considering things like writing back to the func, because obviously a lot of the things that you might see in render output, render input folders during processing of 3 will be written back to the func. So making sure that those things are considered, as well as other areas like attachments that might be written back to disk. So really thinking about those things and thinking about what level of performance the func is going to give us, because that's a core component of the system. Same kind of thing from WAPI perspective. That's ultimately where the code is being executed. So what impact is that having, and how do we test that correctly to make sure that we can understand what's going on and what impact on performance that's having. And then all of the settings and decisions that you've made in terms of how you configure 3E, like your journal manager settings, like your system max row settings, what impact are those things happening? So this application server stack is really key to assess the impact of those settings, because ultimately, as the code is executing on there, it's pulling from database configuration settings to determine how to execute that code. And that's really where we uncover issues and can uncover issues in terms of the overhead of performance. And then finally, the database server stack, which is really where we see probably most of our issues, is in the database server. And this is everything from how the database server is configured all the way through to how it's tuned from an indexing perspective, to file system issues, network issues, all sorts of fun things. But ultimately, everything kind of sits on the database server's performance, right? So you have to make sure that you spend some time assessing the impact of the database server, really thinking through how that can be tuned, and not just doing that as a one-time event, really thinking about how you continuously tune for the workload that you are throwing at your SQL server to make sure that that's being considered. Then from a functional perspective, really what we want to be thinking about here is all of the core components that can influence performance, right? So we've deconstructed the layers of infrastructure. Now what we need to do is assess the types of load profile we want to simulate and the kind of things that we want to consider. So firstly, as I mentioned before, starting with a standard test suite for month-end or year-end load is a good starting place, because that gives you a good undertaking of the system in terms of what a typical high peak load would look like, because that's usually the busiest time of the month for most customers. Thinking about transaction volume from location as well is important, like that scenario we just talked about. Thinking about what's the usage of the system from a Tokyo perspective versus London. Do they create matters and clients, or are they just doing billing? Like all of those things should be considered so that we are replicating the load that is relevant for that location, and giving you a clear picture of what performance might look like in that case. So that standard test suite is really the starting point. Then on the template side of things, really thinking about the impact of templates and template logic. Many times we've found issues with regard to the logic that gets invoked by the template, which then delays the output of a bill, which is really, really key, obviously, to get that out the door as quickly as possible. So making sure that those kind of things are honed in on and assessing the impact of some of the template options, for example, and how that translates to template logic, and then how that translates the timing of producing the output is very key to making sure that we are testing that and testing that at scale to see what that impact looks like. Then from a reports and metrics perspective, making sure that we understand what decisions have been made around any metric development that you might have, any systems that might be talking to 3E, whether that be EDI or any other warehouse solutions that you might have in place, thinking about that, making sure that that's in place for the performance test so that we can, understand the impact of that. And as I mentioned before, thinking about some of the changes that can impact performance overall, like some of those system configuration options like max rows and settings like that can kind of influence the amount of data that's being pulled for every report or metric that you run. Integrations, another really key component, because as I mentioned earlier, upstream and downstream systems will differ from client to client. And obviously, you really want to focus on some of the key ones in terms of anything that's really hitting 3E with a large volume load. It's very important to make sure that we understand what that looks like. And anything that's high frequency really is key, because often what can happen is that when you hit 3E through its transaction services or through the API, through the load, we have to assess that impact in relation to not just it being able to process and throw that data into 3E, but also what happens when you're frequently hitting that same service to go and insert that data while there's 300, 400 people on the system, right? That's really what we want to get to and understand the impact of those integrations on the system, so that again they can be fine-tuned if necessary to make sure that it's performing well and not impacting the user experience. And then security is a big area, because ultimately, depending on how you've configured DLS, that can have a significant overhead that needs to be considered. And again, it's not just about considering the impact of DLS at one or two users, but it's really what happens when everybody's on the system and this code is being invoked to secure your environment. So it's really making sure that that's really efficient and that we're understanding the impact of DLS. So that should be in place for your load test, and make sure that that security design in general is in place, because any element of security from a 3E perspective will have some kind of overhead, and it's important to make sure that that's executed and understood from the outset. And then finally is like other third-party products. Like there's been many times when we will be assessing the impact of 3E on a system, but you could have other third-party products that are also talking to that database, not necessarily through a proper integration, but just being configured to go and query the database to go and feed the product that's there. So often those kind of scenarios are important to consider, because they can obviously add significant load to the database. In some cases, we found third-party products that are not efficiently written, so they're writing queries that are potentially causing locks in the 3E database, which then impacts transactional performance. So what's the secret? How do we fine-tune the system? How do we get it to a point where it's singing nicely and performing well and doing what you need to do? Ultimately, there's kind of these three core main components that we'll talk about. So one of them is, just generally speaking across the system, it's really making sure that from a general perspective, we're thinking about Windows configuration, things like power scheme, setting that to high performance versus balanced is like a first starting point, common thing that we see not set correctly. Antivirus exclusions is a very big area, something that comes up from time and time again. And it's really making sure that best practices are being followed for this. So this is everything from SQL Server following Microsoft's best practice to exclude your data files, your log files from being scanned on access, because that's going to have a big overhead and cause problems with performance. And then thinking about your IIS aspect of it on the WAPI servers, thinking about putting in exclusions for the .NET framework configuration directories, ASP.NET temporary files need to be excluded. IIS configs folders should be excluded, and IIS temporary compressed files should be excluded. And again, these are all Microsoft best practices, but we need to make sure that that's in place across all of the WAPI servers, and it's part of your AV profile to just exclude those from being accessed real time. because that will obviously have a big impact. And then the func, right? So the inet pub folder on the func is another big one, ideally excluding all of that so that that doesn't get impacted through reads and writes that need to happen through the regular working day. Then on the SQL Server side of things, making sure that from a database perspective, that's tuned and correctly configured. So firstly, basic settings like things like max stop and combining that with the cost threshold for parallelism to make sure that your CPUs are not consumed by parallel queries, bad parallel queries sometimes. So you're protecting the performance of the system overall. So setting that to what we expect it to be. So typical recommendation would be half the physical cores up to a maximum of 8, for example, for max stop, and setting your cost threshold to 50, between 50 and 100 is usually a good starting point, and then fine tuning that over time based on your workload is a very key thing to do. And then other things like the workload that's on the SQL Server. So everybody's workload is going to differ. So it's really key to make sure that that workload is assessed and viewed over a period of time so that we understand what the impact of that workload is. And we're going to talk a little bit about that in a bit more detail because this is quite key for the ongoing health of the SQL Server. And then finally, on the network side, making sure that the connectivity between servers is being considered, the connectivity between the client workstations and the load balancer, and then subsequently the WAPI servers is being considered. And we're thinking about latency. We're thinking about if you're virtual, that you've got the right virtual network adapters in place and configured correctly. So what I'm going to do now is dive into some of these areas in a bit more technical detail so you can see some practical advice and not just theory in terms of how this can help you moving forward. So as we've previously kind of touched on, the SQL Server is really the key components of your system architecture where bottlenecks can occur. Really, a lot of time needs to be spent on making sure that from a configuration perspective, things are good. From a workload perspective, that we are analyzing and assessing workload because again, no 2-3 systems are the same. Workload is going to vary. It's going to vary over time. And ultimately, analysis needs to be done on an ongoing basis to really make sure that you are fine-tuning your SQL Server to help you achieve the best possible performance out of the system. So, a few kind of key go-tos in terms of some of the SQL Server DMVs that are available to kind of help do some of the analysis of what kind of activity is happening on the SQL Server. And again, what kind of things can be fine-tuned. So my kind of go-to methods are to start with things like weights. So look at this OS wait times view system DMV view that's available that will give you an indication of what the top wait times are, and then use some of the references that are out there. I've left a couple of links down the bottom there to help kind of analyze those weights and see where those weights are really playing a part in terms of your specific workload. So it's very common for us to see problems on the SQL Server with regard to weights regarding to writing to disk, network, IO, that kind of stuff can come up, and this is a great place to look to go and determine if that's something that's impacting your workload. In addition to that, just looking at the workload from a query perspective and where your top queries are by usage, and also by looking at those queries from different views, right? So here the exec query stats view comes into play, where you can really do some good analysis in terms of seeing your top queries by CPU, looking at it by IO, memory, and looking for poorly performing queries that can be tuned. These views gives you a good indication of what's going on. And then really using the missing indexes view from SQL Server's recommendation engine to help fine tune some of the indexing side of things, right? Because sometimes when you look at all of these things in the context of how often something's running, the type of data it's returning, the volume of data it's returning, and the impact on the underlying hardware resources, using that in conjunction with some of the recommendations that the Microsoft engine is going to make is going to be useful, because ultimately those indexes can have a big impact on improving performance. And just one other thing on the SQL Server side is to always leverage the SQL Server error log. There's usually some really good insight in there in terms of where there are issues. You can see things around memory being exhausted, for example, being logged in there. You will potentially see things around IO requests taking longer than 15 seconds. Those kind of things are very useful to look out for and can help diagnose and improve performance. And then just kind of digging into the workload analysis a little bit further, it's great to look at the queries a little bit more holistically. So this query that I'm sharing here is one from Glenn Berry, well-known SQL Server expert out there. And really one of my go-to queries, because what this quickly gives me is an insight in terms of what workload has happened on the SQL Server since it's been up. And breaks it down by very important pieces of information around execution time, how many times it's been executed, right? So we're looking at the query by resource, we're looking at the query by logical reads, logical writes, looking at the execution count, and then combining that with the DMV for missing indexes so that we can go and see if there is a possibility of tuning that query. So this gives me a very good starting point and would give you a very good starting point to see if there's an opportunity to kind of add an index to improve performance. So good place to start. And then finally, sometimes there is an element of troubleshooting that needs to happen, right? So reactive tools are necessary. Anyone that's spent any time with SQL Server and looking at 3E from a SQL Server perspective will obviously know that there's lots of activity that's typically happening on your core system. And using tools like SPWho or SPWho2 is great for giving you an insight in terms of everything that's running at that point in time. But leveraging some stored procedures like SPWho is active is really, really helpful because it just allows you to focus on truly active SPIDs, so that you can go and research what kind of activity they're having and taking away a lot of the noise that you typically see with some of the system SPIDs and anything that's inactive or sleeping. On the func side of things and on the WAPI side of things, like really using standard tools like Task Manager to go and see, what the usage of your W3WP process is always helpful starting point, to see, what the memory consumption looks like, what the CPU consumption looks like, to see if there are any outliers, right? So if you see one particular WAPI using a higher amount of CPU on a consistent basis and maybe flatlining at 100%, it's usually an indication of some poorly performing code, which needs to be diagnosed a little bit further. So in those kind of scenarios, the go-to kind of method of analyzing that further is to go and break down what's happening within the W3WP process. So taking a memory dump, using tools from Microsoft like Debug Diag to go and analyze a memory dump, so that you can then go and see exactly what was running on each thread within that W3WP process, so that you can really do a better job of diagnosing where the source of the issue comes from. Then on the browser side of things, obviously the developer tools by hitting F12 gives you some really helpful information. Great place to start is on the network tab to go and understand what's passing back and forth between your client workstation and the server. And I'll give you kind of an example of this in a moment in terms of what you can do with that output to really determine where your problems might lie, and then go about really focusing on how to improve those issues. And then finally, from a 3 specific perspective, using one of the really useful framework options in terms of log include context, which is available in the override system options page. What this allows you to do is include really pertinent information in the 3 logs, which would include things like the process item ID, process, session ID, and page, so that you can actually tie back SQL Server sessions to a specific process that's been executed, which is super valuable and gives you great insight in terms of what's happening. And again, there's some useful links here in terms of what you can do with regard to the browser. The Heart Analyzer from Google's toolbox is really, really useful. And that's what I would just kind of give you a view of at the moment. So if you look at the screenshot below, what it shows you is a real world scenario where we're troubleshooting performance of 3E, particularly from the browser. And what we're able to do is take that Heart output from Chrome to kind of dump that out to a .har file, which is basically a HTTP archive, and then take that and feed that into Google's analyzer to go and understand, exactly where the time is being lost. And in this case, we were very quickly able to see that we're losing a number of seconds per process load through what looks like what appears to be a network issue, right? Because ultimately the receive time that you see on the right hand side is around 2.3 seconds every time we go and hit a particular process, which generally indicates that the server's done what it needs to do and it's now in transit back to the browser. So ultimately something on the network is causing a problem, and this is where you can then take your investigation further and figure out, is there a firewall in the middle of you and the server? Is it adding some kind of overhead? Is there AV in place that's causing some overhead? or is your network route inefficient? So, measuring the number of hops using simple tools like traceroute can help to kind of diagnose how those things are coming about and how they can ultimately be improved. And yeah, just really gives you good insight in terms of all of the components of what happens when you click a button in 3 all the way through to, it going to the server, doing its bit, and then coming back. So combining this with some of the SQL analysis that we talked about earlier, and then combining that with some of the 3E logs is really the kind of useful way of being able to diagnose some of these issues a little bit further. So just kind of circling back to the beginning, really what we were hoping to do today, and what I hope we have done today, is really give you a view of the different approaches to performance testing and whether or not you take the reactive and proactive route. Obviously, our goal here is to empower you to think about performance testing right at the beginning of your project so that you plan for it. You get to a point where you can really go into your go live or upgraded instance go live with confidence that the system is going to perform when all of the users get online and start using the product, and really enjoy the experience of using 3E. So I hope that's been helpful for you. Please visit the link below, helm360.com/3E, for further information around our testing services and how we can kind of help you with some of the items that we've just talked about, including automating load. And finally, thank you for listening today. If you would like to enter a raffle for a free 3E performance audit, please follow the URL as you see on the page there. And if you have any follow-up questions outside of the chat today, please feel free to drop myself or Sue an email, and our email addresses are listed there. Thank you very much.